In this lesson, we're going to be talking about factoring trinomials that have a leading coefficient of 1. First, we want to recall how we multiplied binomials. For example, the binomial x plus 2 times x minus 5. And you might remember FOIL. We take the first, x squared, times the outside, minus 5x, times the inside, plus 2x, and then the last, minus 10. When we combine like terms of negative 5x plus 2x, we get x squared minus 3x minus 10. So that's foiling multiplying binomials, but now we want to work on factoring these trinomials meaning 3 terms there, back into 2 binomials. And what I'm hoping you recognize is that the binomials will follow a similar form. We're going to have x plus some number, such as 4 and 3. Sometimes we might have something being added and subtracted. Or maybe sometimes we'll have 2 numbers that are being subtracted. X minus 5, x minus 6. These are just arbitrary. The forms are going to be similar. Are they always going to look like this? No, but it's a good thing to recognize. So, in this PowerPoint, we're specifically looking at what does a trinomial with a leading coefficient of 1 look like. Well, when I say leading coefficient, I'm looking at the number in front of the x squared, the highest term. And the number in front of this one is 1. The coefficient is 1, versus this binomial, which has a leading coefficient of 3. The other key term we need to know is the constant. The constant is, in this case, negative 6. It's the number that looks like it's not being multiplied by an x. Typically we have these in x or any other variable that might be included in the trinomial set. So, in factoring trinomials with a leading coefficient of 1, we're going to be looking for the pattern of products and sums. What does that mean? That's something we're going to talk about. Many students, you may have been working with guess and check, and guess and check is a good method, but we're going to try to have a more mathematical approach to this. So, to start off with, when we're looking for a pattern of products and sums, we are going to look for all the pairs of numbers that multiply to the constant, in this case 12. And so we have 3 sets of numbers, 1 times 12, 2 times 6, and 3 times 4. Next, we need to choose the pair that adds up to the middle coefficient. And the middle coefficient is 7. Okay, the middle term of 7x, the coefficient is 7. Which pair adds up to 7? That would be 3 times 4. So now we're going to rewrite the trinomial as a product of 2 binomials, like we saw before. X plus 3, x plus 4. And if we FOIL, or if we use distribution, we would get x squared plus 4x plus 3x plus 12. Or in other words, x squared plus 7x plus 12, our original trinomial to be factored. Let's look at another example. X squared plus 2x minus 24. Note that the constant here is negative, a negative 24. So now to list all the pairs of numbers that multiply to the constant, negative 24, we're looking for one number to be positive and one number to be negative. Okay, I've listed all the possible options with negatives and positives, but as we continue to look at this, we should see that we have a positive 2x that we're adding to, meaning we want the larger of the pairs of numbers to be positive. In this case, that is my second set here. So we're namely going to be looking at that second set where the larger of the 2 factors is positive. So which pair adds up to the middle term of a positive 2? That would be 6 and negative 4. So now we're going to write that as a pair of binomial factors. And this time we're not going to do x plus 6, but our next term is x minus 4 because we had that negative in there. And foiling or distributing to make sure that we have our answer, we would have x squared minus 4x plus 6x minus 24. Combining like terms, I have x squared plus 2x minus 24, my original answer.